Form 5 Mathematics, Chapter 9, Section 9.6. In this section, we will learn some applications of standard deviations. For Part A, we will learn a very useful statistical measure called standard score. Firstly, let's look at a warm-up activity. Here, you are given Mary's score in 2 different tests in her class. Her English mark is 65 and mathematics mark is 68. And the mean mark of both of the 2 subjects are 60 and 62 respectively in this class. Question 1. In which subject did Mary get higher marks? Okay, if we only focus on the marks, you can easily see that Mary got higher marks in mathematics. 68 is greater than 65. So you just write down mathematics for question 1. Question 2. How do Mary's scores compare with the mean marks in her class? So you just compare Mary's mark with the mean marks. For English, 65 is greater than 60. So her mark is 5 marks above the mean in English. And she got 68 in maths. So it is 6 marks above the mean. Question 3, based on the results of question 2. In which test did Mary perform better in the class? Okay, so if we only consider the marks above or below means, here you can see that 6 is greater than 5. So we can conclude here that Mary performed better in mathematics. Question 4. Here, you are further given the distributions of marks of the class in the 2 subjects, Maths and English. Okay, from this figure, the distribution of marks, okay, you can see the vertical axis is frequency. That means the number of students who got the marks in the class interval. And you see that, okay, for this diagram here, there are more data in the middle of English. So we can say that the data is more concentrated about the measure of central tendency. And for mathematics, you see that there are more data below 62 or above 62. So in this case, for mathematics, we will say these data sets are more dispersed. So here, for Part A, you can just conclude the dispersion of marks in maths is greater than that in English. So the number of students who marks above 68, okay, will be greater than the number of students whose English mark is above 65. Okay, you see here, the frequency is less. That means less student. So, okay, here, by comparing, that means Mary performed better in English. Okay, she is the top student in English. And so here, apart from Mary marks and mean marks of the class, we should also include the dispersions of marks of the 2 subjects in conclude in which subject Mary performed better. So here we will also include the measures of dispersions of the marks in the two subjects. Here, we have small conclusions. If we want to compare Mary's performance of tests in the class, we have to know Mary's actual marks and the difference between the actual marks and the mean marks of the groups. And also, for better comparison, we have to also observe or have information about the dispersions of the marks of the group. From the warm-up activity, we see that in order to compare a datum with the data sets, in different groups or in different aspects, we have to do some standardizations on the marks to help. Here in statistics, we have a very useful statistical tool called standard score. We also call this set score. We usually use the letter Z to represent standard score. And here, when we want to calculate standard score, we have the following formula. If we use X to represent the datum, the values of the datum, and use X bar to represent the mean of the data set, and use sigma to represent the standard deviations of the data set, then the standard score of the datum will be X minus X bar divided by sigma. That means when we want to know the standard score of the datum X, we have to know the mean and the standard deviations. And then by using this formula, we can calculate the standard score of the datum in this data set. We can interpret the standard score as follows. The standard score actually measures how far away a datum lies from the mean. We are comparing the datum with the mean of the data set in units of the standard deviations. Here, let's say the standard score, if the standard score is equal to 1, that means the datum is 1 unit above the mean. 1 unit of SD above the mean. If the standard score is -1, then the datum is 1 unit of SD below the mean. And there are some notes for standard score. For the standard score, the denominator and the numerator both have the same unit as the data set. So by divisions, the units are cancelled. So standard score has no unit. When we have the datum X is greater than the mean, by considering the formula for the standard score, for the denominator, standard deviation must be positive. For the numerator, when X is greater than, the datum is greater than the mean, it is positive. So positive over positive is positive. So the standard score in this case is positive. Similarly, when we have x, the datum is less than the mean, then the numerator is negative. So set the standard score is negative. The third case, when x is equal to the mean, then set equal x minus x bar is 0. 0 over sigma equals 0. So for this case, the standard score is 0. And we can interpret that, okay, if the standard score is more positive or negative, then the datum is further away from the mean. Let's study one example, 9.6.1. Here refer to the previous activity. Now, if the standard deviation of the test in both subjects are given. A. Could you find the standard scores of Mary in English and mathematics? Here, you are asked to find the standard score. So every time you see the standard score, just try to write down the formula for yourself as reference in the rough worksheet. Here, okay, we have the values of the datum. Okay, say for English, you have, this is x, and the mean and the standard deviations. So for part A, you can just write down for English, the standard score of Mary's marks, okay, is just equal to the datum minus the mean of English is divided by the standard deviations of the subject. So you got 2.5. And similarly, for mathematics, okay, Mary standard score, you just use the set of values from mathematics. Okay, you have for mathematics, this is x, this is the mean, this is the SD. So 68 minus 62 divided by 3, and then you got, this is 2. So these two are what's required in the questions. B. In which test did Mary perform better? You have to interpret what it means by performing better. Performing better means have a higher marks, okay? Because the marks are in different subjects, so you have to compare the performance of Mary in these two subjects by considering the standard score, but not only studying the marks. So for part B, okay, when you compare the standard score of Mary marks in English and mathematics, you see that this is greater. So that means Mary performed better in English. So you just write down Mary's standard score in English, okay, which is equal to 2.5. This is greater than her standard score in mathematics, okay, which is 2. So after comparing the standard score in these two subjects, you can conclude that Mary performed better in English. Now, just recite the formula for standard score. Okay, the datum minus the mean divided by the standard deviations. Then try to finish the classwork. Question 1, 2, and question 3. You can just stop the video and try to finish yourself on the worksheet. And then you continue the videos and look for the answers. 好啦，咁我哋咧睇個 classwork， 咁其實就好簡單，用 standard score 個 formula 啦，就係個 datum 減個 mean 除翻個 SD 啦。咁我哋咧睇第二題先。咁第二題咧，咁咧就問啲好簡單嘅嘢，就問 who 有一個分數 above mean 同 below mean。咁咧就好簡單嘅啫，你就係需要咧 compare 個 datum 同埋個 mean。咁如果大個嘅，咁個 standard score 就係正數啦；如果細個嘅，咁個 standard score 就負數啦。咁所以咧，佢如果去問 above mean 嘅，咁咧即係問緊個 standard score 要 positive 啦。咁所以就會有 Betty 同 Connie 啦。咁如果係 below mean 嘅 ，below mean， 咁咧個 standard score 咧就要 negative 啦。咁所以就有 Sally 同埋 Teresa 啦。咁如果係 equal to 個 mean 嘅，咁咧就係即係個 x 等於個 datum 等於個 mean 啦。咁所以個 set 就等於0啦。咁就係 I win 啦。咁睇埋第一題啦，第一題就其實都係重複咁用呢條式啦，等你熟習背咗佢啦。咁其實好簡單啫，4個 unknowns 有3個，咁你塞翻入條式，咪計到剩低嗰個咯。咁同埋你可以 check 下自己啱唔啱嘅。咁啱啱講過啦，如果個 standard score 係 positive 嘅，咁你就知個 x 咧就會大過個 mean 啦。咁呢個粗略嘅去睇自己嘅答案啱唔啱啦。咁如果個 standard score 係 negative 嘅，咁個 datum 咧就細過個 mean。咁第三題 part A 就俾咗阿 Ken 嘅分數喺4個 test 入邊啦，就叫你揾翻呢4個 test 阿 Ken 嘅 standard score 啦，個標準分啦。咁呢度只係其實就係想你熟讀條式啦，咁就不停咁重複用啦，咁就攞到嗰4個 answers 啦。好啦，到 part B1 啦，咁就叫你去比較 Ken 嘅分數喺 test 1同 test 2啦，問邊科相對地係 perform 得好啲啦。咁又要理解啦，咩叫做 perform 得好啲啦。咁喺全班入邊，相對地佢比個 mean 嘅 marks 越高，而係啦 ，in terms of SD 咧，佢越多咧就即係個表現越好啦。咁所以呢度你就睇到啦，一個係正，一個係負啦。咁即係呢度就 above 個 mean mark 啦。個 test 2咧就係 below 個 mean mark 啦。咁正數就係好啲啦。咁所以係 test 1啦。咁好啦，到 part B 啦。咁就比較 test 3同 test 4 Ken 嘅 result。咁喺邊個 test 咧？阿 Ken 又係喺呢班度相對地個表現係好啲啦。咁呢度咧，你睇到咧兩個都係正數喎。咁即係都係比 mean 高分啦 ，above mean 啦。好啦，咁如果個 test 3佢個 standard score 咧就係1，咁即係咧你可以咁樣理解 Ken 嘅表現咧就係1個 SD above mean。咁而 test 4咧 個 standard score 咧就0.5，嗱就唔係0.5分啊。standard score 咧記住咧係冇單位嘅。咁 test 4 Cans 嘅 standard score 係0.5，即係你可以理解為咧佢個分數咧喺呢班入邊咧就係0.5個 SD above 個 mean。咁所以喺呢度咁越 positive 嘅，咁就即係表現越好啦。咁所以咧就答 test 3啦。